Hi, welcome to our final project. We did real-time melting simulation using springs.
So the goal for this project was to create a real-time melting simulation. So this is very similar to a cloth simulator. And instead of a 2D plane, we create a 3D lattice of point masses and springs. And at each time step, we update all the values that are necessary.
So the first step to doing the simulation was to simulate heat propagation. And to do this, we used the heat equation. So our process was that we found the average surrounding temperature for a given point mass, and then computed the difference between that average and the current temperature of the point mass. And then the rate of change for that point mass was then proportional to our computed difference. And then, so for after that, for coloring the point masses, we just lurk between HSV values for cold and hot, depending on temperature. So you can see here in our heat propagation demo that in the beginning, only the left point is heated. And once the simulation begins, heat propagates through the entire metal bar. And that's why you can see the colors changing. So in our next demo, this time we heated the left half of the bar initially and kept the right half of the bar initially cold. And then once the simulation begins, you can see that heat propagates and that it evens out throughout the metal bar.
So how we applied melting was we fit a curve using a cubic spline. And this curve would map the temperature to the spring constant. So then we would scale the spring constant to a ratio and multiply it to the spring constant that we were currently using. In addition, we had to add vibration because the cube would come to rest without any external forces. So the vibration would be like a micro external force that would cause the cube itself to melt. So here's a quick demonstration of our final product. Only the bottom left particle is being heated up, and you can see it kind of collapses on that particle because the heat is propagating from it. Here's another demonstration, except this time the entire bottom plane is being heated, so the heat propagates upwards, and you can kind of see it collapses plane by plane.
Yep, and that's pretty much it. Thank you for listening.